Subgraph of G. V dash is subset of V. E dash is subset or equal to E. V dash is subset or equal to V. E dash is subset or equal to E. Subset or equal to V. Subset or equal to V. So, and each edge of H has the and each and each and each edge of H each edge of H each edge of H each edge of H has the same end vertices in G. Same end and vertices of what you and vertices same and vertices in H. Vertices in H as in G as in G as in G. So in particular, V belongs to capital V, G belongs to in G, and G is the subgraph of the G. And plus V is the subgraph of G obtained by deleting V and all edges G containing V. So here one diagram. I'll put down diagram. Suppose here. Suppose diagram is there. Suppose this diagram vertices are A, B, C, D is there. A, B, C is there. Here, this is the graph. So subgraphs. What are the subgraphs? Subgraph of G. Subgraph of G. Subgraph of capital G are. Observe here. DAC. Suppose like that is there. DA. DAC. DAC is the subgraph of G. And one more. Suppose like that is there. ABC. 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 ABC is also subgraph of these two. One, this is considered 2. 1 and 2 1 comma 2 are the subgraph of subgraph of subgraph of G. Subgraph of G. Subgraph. Okay. Next. Next example. Here. Let us be the here. Let us have the practices. Here, for example, you see page number 133. If G is a simple graph, G is a example. Page number 133. If G is a simple graph, 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 G is a simple graph, a simple graph with 15 edges, with 15 edges, with 15 edges, 15 edges, and G bar has 13 edges, and G bar has 13 edges, means complementary graph of G. This G bar means 13 edges, 13 edges, 13 edges, 13 edges. And how many vertices does G have? Then how many? Then how many edges? How many edges? Edges G have? How many edges G have? Solution. 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 How many edges? Solution. Suppose G has a vertices and edges. Suppose G has n vertices, m edges. Let 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 G has n vertices, n vertices, n vertices, and m edges, and m edges, n edges, n edges. We know that the vertices set as WKT, means we know that the vertices set S set as vertex set as set S vertex set S with n elements with n elements n elements with n elements can have NC2 can have NC2 can have NC can have NC2. That means n into n minus 1 n into n minus 1 by 2. By definition of complement of a graph, here G is the graph, G bar is the complement. By definition of by definition of complement of a graph, by definition of complement of a graph, complement, by definition of complement of a graph, by definition of complement of a graph, we have V of G, we have V of G bar, V of G bar, that equal to V of G, V of G, and E of G bar, and E of G bar, V of G bar, that equal to V of G bar equal to, that is mod x comma y, x comma y, x comma y, x comma y, comma y, x comma y, such that comma y, x comma y belongs to E of G, where x comma y belongs to x comma y belongs to E of G, E of G. Hence, then the number of edges in G bar, then the number of edges in G bar, in G bar, n G bar, number of edges in G bar, that equal to n into n minus 1 whole divided by 3 minus m. That means here 13 equal to 13 equal to 13 equal to n into n minus 1 whole divided by 2 minus 15 minus 15, because these values are given in the question. So simplification, by simplification, n equal to 1 well equal to n into n minus 1 by 2, that equal to 15 by 1, that equal to n minus 2 n into n minus 1 minus 30, that equal to 13. So by cross multiplication we obtain, by cross multiplication, by cross multiplication, by cross multiplication, we obtain 13 into 2. 13 into 2 is 13 into 2, 13 into, by cross multiplication, 13 into 2, that equal to 13 into 2, n into, multiply n square minus n minus 30. That means 13 2 is 26. That equal to n square minus 30. So transpose one side. That implies n square minus n minus 30 minus 26. That equal to 0. So that implies n square minus n minus 56. That equal to 0. So split the middle term or using factorization method. N square minus 8n, 8n minus plus 5n, 7n, because 7 8 is 56, plus into minus minus, that equal to 7n minus 56 that equal to 0. First two terms, n is common, n minus 8 plus 7 common, here n minus 8 that equal to 0. So total common is here, total common is here, total common is n minus 8. Rest is n plus 7 that equal to 0. That means n minus 8 equal to 0, or n plus 7 that equal to 0. So that here n equal to 8, or n equal to minus 7, because negative value negligible. Negative value will neglect. N equal to 8. So the given graph G has 8 vertices. So negative value neglect. Negative value is neglect. Negative value neglect. So the graph G has 8 vertices. So the graph G has 8 vertices. Graph G 8 vertices. Graph G has vertices. Okay, understood? Next, one more sum, because in my home there is no power is there. So the laptop charging also going down. So isomorphism. Definition of isomorphism. 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 Definition. Isomorphism definition. Isomorphism definition. Let G V comma E. Let G V comma E. V comma E. And let G V comma E and so G V1 comma V1 comma E1, that is G1 comma G2 V2 comma E2 G2 comma V2 B is two simple graphs. B two simple graphs. Simple graph. B simple graphs. B simple graphs. We say G1 isomorphism. We say isomorphism. We say G1 is G1 is isomorphism isomorphism uh, isomorphism to G2. What is isomorphism? This isomorphism we listen in on algebra. Listen algebra. Algebra. What is the isomorphism we learn this year? So, G, B isomorphism G1 is isomorphism to isomorphism G2. Then we say isomorphism to G2. Then we say G1 is isomorphism G2. Here G1 is isomorphism to G2. Then if it sets, if it is satisfies, if it satisfies, satisfies, it satisfy 1, 1, and on to, and it satisfy inverse, inverse, inverse 1, 1 on to inverse is called the isomorphism. Isomorphism. This we denoted by G1 congruency to G2 will known as. So based upon this, one theorem is there. The battery is low is going on my laptop. So one theorem, that is 8.5.5 theorem 8.5.5, one theorem 8.5.5, 8.5.5. So do it as homework. 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 Homework. Because my battery is low down is going on. Power is not the homework. 8.5. Homework you do it. One more example. Here 8.5.3 example. 8.5.3 also, because my laptop is low down. It's saying red mark is coming. Okay, I'm leaving tomorrow.